The Amiga Revista, the first one for BC Calc. What we're going to talk about here is limits using a graph. The first thing I want to know is limit as x goes to negative infinity. So I'm coming from the right and I'm going to the left, and as I approach negative infinity, notice how this line tails towards 0. The y value as x goes towards negative infinity is the y value of 0. As x goes to positive infinity, so that's going this way. Again, it slopes down. I don't have much room to keep going, but it's going closer and closer to 0. The limit as x approaches negative 6 from the left. So this is 0, 0, 1, 2, 3, 4, 5, 6. The limit as x approaches negative 6 from the left. What y value am I getting closer and closer to as I get closer and closer to negative 6 from the left? And the y value that I get closer and closer to is the y value of 1. The limit as f of x approaches negative 6 from the right. So I'm no longer coming this way, I'm coming from the right. And as I get closer and closer to negative 6x value from the right, what y value am I getting closer and closer to? 1, 2, 3. The y value is 3. Now, as I get closer and closer to negative 6 from both sides, because there's no left-hand or right-hand limit there. So negative 6 from both sides. So coming from the left is in this direction, coming from the right is in this direction. Do they meet at the same point? No. Because they don't meet at the same point, there's a gap, which we call a jump discontinuity. The limit does not exist. For number 6, as x approaches negative 3 from both sides. Negative 3 from both sides. So as I'm coming closer and closer to both sides, it's almost like I'm popping a pimple. What value is going to be there, whether it's shaded in or not? What value am I getting closer and closer to from both sides? And the answer to that is positive 2. As I approach 0 from the right, as I approach x value 0 from the right. From the right, it's coming this way. And I approach y value, negative 1. As I approach 0 from the left, what y value am I getting closer and closer to? 4, 5, y value 5. As I approach 0 from both sides, from the left and the right. From the left, it's getting closer to 5. From the right, it's getting closer to negative 1. They do not meet. It is a jump discontinuity. So the limit is d and e. Does not exist. The limit as I approach positive 3 from the left. 1, 2, 3. It looks like it's an asymptote. So as I approach positive 3 from the left, the y value approaches positive infinity. As I approach positive 3 from the right. As I approach positive 3 from the right-sided limit. So I'm approaching this 3 from the right. Again, it goes to positive infinity. As I approach 3 from both sides. Because they both approach infinity, I'm going to say the limit as x approaches 3 from both sides is also infinity. 5 from the left. As I approach 5, 3, 4, 5 from the left, I go to negative infinity. As I approach 5 from the right, I go to positive infinity. As I approach 5 from both sides, I don't even have to look at the graph because these do not match. The answer is d and e. It is a jump discontinuity. The limit as I approach 6 from both sides. There's 6 from both sides. As I approach 6, I get closer and closer to the y value of 1. As I approach 9 from both sides, 7, 8, 9 from both sides. That's the left and the right. Notice they do not meet. There's a jump discontinuity. So that's going to be d and e. Now, I'm not asking for the limit. I'm asking for the y value given the x value, not the limit. This is like a plug and chug if I were to give you the actual expression. So I want to find out what the y value is when x equals negative 6. Negative 1, 2, 3, 4, 5, 6. The x value is the shaded in bubble. So the x value is negative 1. The y value is negative 1. When the x value is negative 6, the y equivalent is negative 1. When the x value is negative 5, when the x value is negative 1, 2, 3, 4, 5, what is the y value? 1, 2, 3, 4. The y value is 4. When x is negative 4, what's the y value? 1, 2, 3, 4, 5. When x is negative 3, negative 1, 2, 3. No, it's not the limit. It's the actual closed circle, 3. When x equals negative 2, the y value is positive 1. When x equals 0, no, it's not down here. It's this y value up here, 5. When x equals 1, I know the curve and the limit is up here, but the actual value is down here at negative 2. F of 3, there's no value there. That's d and e. Even though the limit approaches infinity, the value at 3 is an asymptote, a hole. It doesn't exist. At 4, 3, 4, the y value is 1, 2. At 6, 5, 6, the y value, the limit is here at 1, but the actual y value is 6, 0. Whoops, y value 0, 6, 0. At 7, it's this closed circle, so it's 7, 0. During the test, I'd like you to just fill in the answers so I can grade it rapidly. Like the answer to number 1 would be 0, 0, 3 would be 1, 3. This way I can grade it rapidly and get the results back to you quickly. For 21, I want you to use the limit definition to evaluate the derivative. No, you don't have to work it out. You don't have to do the difference quotient. You just have to recognize that this is the f of x, and you want to find the derivative, all right, of sine 4x. And I believe we did that in class. It's going to be 4 cosine 4x. Okay, number 30, we're going to graph a simple line. So y equals mx plus b. I d-gain at negative 1, and the slope is 2 over 1, so I go from that point up to 1, 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Continue the process down to left 1, down to left 1, down to left 1, and I connect the dots. And that's my line. Now I know the x-intercepts. The x-intercept of this is going to be 0.5, 0, or 1/2 0. You can do it by setting it equal to 0 or by looking at the graph. The y-intercept, you can see instantly, is going to be negative 1. So 0, negative 1. The interval where it's continuous, it's a line, and it is continuous everywhere, from negative infinity to positive infinity, and that is the interval notation. There is no local max. There is no local min. The interval, it is increasing. It's continuous, it's increasing on all reals. So again, from negative infinity to positive infinity. Now I'd like to graph this parabola, who has a vertex at 1, 1. So I go to 1, 1, and I place my point. Now, parabolas with no leading coefficient or a leading coefficient of 1 have a special property of 1, 3, 5 is the distances apart. So from here, I'm going to go up 1 over 1. Then I'm going to go up 3, 1, 2, 3 over 1. Then I'm going to go up 5, 1, 2, 3, 4, 5 over 1. Go back to the vertex, up 1 over 1. 1, 3, 5. Up 1, 2, 3 over 1. Then up 5 over 1, and it takes me off the graph, and I'm going to connect the dots. The x-intercepts, none. Y-intercepts, I can see it from the graph that it's going to be 2. So 0, 2. The interval is continuous. It is continuous on all reals, from negative infinity to positive infinity. There's a local max? No, none. There's a local min. The coordinate of the local min is the vertex, which is 1, 1. The value of the local min is this y value, which is just 1. The interval, it is increasing. It doesn't start to increase until I reach this coordinate here, and then it's going uphill. But at this coordinate, it is neither increasing or decreasing. So I have to put open parentheses, 1, x value, it starts increasing, to infinity is the interval, it is increasing. Now I want to do the piecewise defined. It's kind of easy to do when you have both graphs in front of you. Something weird or wonderful happens at x value 1, so I'm going to put in a little hash mark there. You don't need that, and you shouldn't really have it. I'm going to put in a little hash mark here. You don't need that, you shouldn't have it. I'm going to put in a little hash mark here. You don't need it, you really shouldn't have it. But that's where something weird and wonderful happens. Notice, 2x minus 1, I'm allowed to graph where x is less than 1. Less than 1. So over here, at 1, I'm allowed to graph it to the left. So I'm going to transfer that point over to this number 32 graph. And notice, I'm not allowed to go up 2 over 1, because I can only graph to the left. So I'm going to go down to left 1. Down to left 1. Down to left 1. Down to left 1. I'm only allowed to graph to the left. It's a domain restriction. Now, for x squared minus, or x minus 1 squared plus 1, I'm only allowed to graph to the right. And notice, that magic point happens there at 1, 1. So now I fill this in. And from there, I go up 1 over 1. I implement the 1, 3, 5. Then I go up 1, 2, 3 over 1. 1, 2, 3, 4, 5 over 1. And it continues off the graph for infinity. Now I want to answer some questions. The x-intercept. The x-intercept now is here, which is 0.50. 0.50. The y-intercept, 0, negative 1. The interval is continuous. It is continuous, closed circle, on all reals. So from negative infinity to positive infinity, it is continuous. A local max, I believe there are none. A local min, I believe there are none. This is no longer a min because the point right next to it is below it. The point above, to the right of it is above it, so that's not considered a local min. The interval, it is increasing. Now this is tricky. It is increasing all the way up until this open circle on this line. If that was a closed circle for the line, it would be increasing on all reals. It looks like it's increasing on all reals, but at one fraction of a moment, it's not increasing there. So it's increasing from negative infinity to 1, parentheses, union. It may sound strange, but it starts at 1 again and starts increasing to positive infinity. Find the x-intercepts. All I want to do is set the top equal to 0. The bottom would be the asymptotes or points of discontinuity. The x-intercepts are just setting the top equal to 0. So that's going to give me x equals 2. Solve the system. This one's a little involved, so I'm going to change the signs at the bottom, and then I'm going to solve it like I would a normal system and eliminate the y's. So x squared minus x, the y squared flake away, equals 1 plus 5, which is 6. I'm going to bring that over, and that gives me x squared minus x minus 6 equals 0. I think I can factor this. This is going to factor to x times x, 3 times 2 equals 0. And then because the middle term is negative, it's going to go with that, and this is going to be positive, so when I use the ZPP, zero product property, I get x equals 3. X equals 3, and x equals negative 2. I'm not done. I have to find the y values, and there are 2 of them. So I have negative x plus y equals 5, and an x value of 3. I have negative x plus y equals 5, and a y value of negative 2. When I plug the 3 in for x, that gives me negative 3 plus y equals 5. I add 3 to both sides, and I get an 8. When I plug in negative 2, that's negative 2, that's 2 plus y equals 5. I subtract 2 from both sides, and I get 3. When the test, I'll have 2 lines there for you, and the coordinate, so you don't get confused. So the answer is going to be 3, 8, and negative 2, 3. And it doesn't matter what order you put them in. The 3, 8 first, or the negative 2, 3 first, or the negative 2, 3 first, or the 3, 8 second. Find the slope. The formula for slope, old school stuff, is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And it's up to you which one you want to choose. So I'm going to set up a big fraction bar. I'm going to do 1 minus 5 halves. And I'm going to do 3 halves minus 5. 5 halves would be, or 5 would be 10 halves. Rewrite it with the common denominator. That's going to give me negative 3 halves on top. And negative 7 halves on bottom. When I keep it, flip it, change it, I'm going to multiply it by negative 2 sevenths. And notice the 2's cancel out and the negatives simplify. And that gives me an answer of 3 sevenths. write the equation of the line passing through the point with the indicated slope. So I'm going to implement the formula y minus y sub 1 equals m times x minus x sub 1. And it's basically just a plug and chug. So y minus minus 5 equals the slope, 2/3, times x minus 3. I distribute the 2/3. That gives me 2/3 x minus 2. Because 2/3 times negative 3, the 3's cancel out. Now I have to subtract 5 from both sides. And my equation is going to be y equals 2/3 x minus 7. This one's a little bit more tedious. I have to find the equation of the line passing through the 2 points. First step, find the slope. So it's going to be y2 minus y1, so 5 minus minus 1, 5 minus negative 1, 5 minus negative 1, over negative 5 minus 10. That's going to give me 6 over negative 15. That simplifies to negative 3, or 3 goes into 6, 2 times, 3 goes into 5, 15. Now I have to choose a point. I'm going to choose the 5s. Y minus y1 equals the slope times x minus x sub 1. Negative 5 makes it a positive 5. Distribute. That gives me negative 2/3 x minus 10/3. Now I have to add 5 to both sides. So I'm going to add 5 over here. Notice I rewrote it with the common denominator. 15 divided by 3 is 5. So my final equation is going to be y equals negative 2/3 x. 15 minus 10 is plus 5 over 3. Evaluate the function using the difference quotient. And I must show all my work. Alright, here we go. It doesn't say limit. So I think I just have to use the difference quotient, which is f of x plus h minus f of x all over h. So this is going to give me a big division bar with a minus sign all over h, and what goes in the back is the actual function, 2x squared minus 4x plus 7. What goes in the front is a little bit more tedious. Wherever there's an x, I'm going to put grouping, and the x plus h goes into the grouping. Now I have a lot of tedious algebra to do, so it would be nice to know what the quantity x plus h squared is, x plus h squared, and that's going to give me x squared plus 2hx plus h squared. I'm going to continue with the tedious algebra, minus 4x minus 4h plus 7. Continue, distribute the negative. Negative 2x squared plus 4x minus 7. Taking up a lot of room. I'm going to continue. I'm going to distribute the 2 now. It's still all over h. So it's 2x squared plus 4hx plus 2h squared minus 4x minus 4h plus 7 minus 2x squared plus 4x minus 7. And now I'm going to seek out for anything that cancels, any like terms. And I like to work from the back end. So negative 7 cancels out with positive 7. Positive 4x cancels out with negative 4x. Negative 2x squared cancels out with positive 2x squared. And that leaves me with 4hx plus 2h squared minus 4h all over h. And notice I can factor an h out of each of these items. The h's simplify, and my final answer is going to be 4x plus 2h minus 4. Don't forget there's a shortcut to this. There's a shortcut to this, but it says for this particular case, I want you to show all your work, and notice it's worth 10 points. This one is a whopper.